Hello. Today we are going to see a little bit about our continued discussion on permutations and combinations. And we are going to see uh, linear arrangements in how many ways certain things can be arranged satisfying a given criteria. So this is under uh, quantitative part 1, reading 3, probability concepts, permutations and combinations. We have some videos and solved example, but we are going to solve this second problem. If you'd like to pause the video and go through the problem description, you can do that right now. There is a conference summit G7. That means there will be 7 representatives from 7 countries, let's say. In one of the meetings, it was decided that the representative from the richest country is not supposed to sit immediately next to the representative from the poorest country. In how many ways the seating arrangement can be done, assuming they sit in a straight line? Uh, there are several ways, but first of all, let's see the key terms here. They sit in a straight line. So whatever I'm going to discuss right now belongs to linear arrangement, as opposed to most of the times these representatives actually sit in around a circular table. So that would be a circular arrangement, which is totally different. There, the number of degrees reduces by 1. So the key point is they sit in a straight line, and there are 7 representatives. Now it's very difficult directly to find out manually how many ways this condition can be satisfied. So we are going to solve using some alternative approach, using the concept of complement of an event. The problem is completely solved, and if you would like to see the description, solution, you can do that. But I'm going to solve this problem. Let's first find out. Let's call it as step 1. In step 1, uh, all possible arrangements. In all possible arrangements, we will disregard the given criteria. And since there are 7 people can be arranged among themselves without any restriction in 7 factorial ways. Uh, that's because if you are taking if you are taking all people from that particular set, so this and where the order is actually important, so that gives rise to permutations. So another way, I will say, or another way to see this, why this comes out to be 7 factorial ways, is you have 7 people, and then the order is important. So this is 7p7, and you are selecting all. So using the formula n factorial upon n minus r factorial, so that would be 7 factorial upon 0 factorial. Remember, 0 factorial is not 0, it's actually 1. So this will give rise to 7 factorial. So, which is same as this one. So that is our step 1. In step 1, we found out all possible arrangement means without any restriction, how many ways these 7 people can be arranged among themselves in a linear manner. Okay. Now, we want to make sure that these 2 representatives are not sitting together. So what we'll do is we'll do the exactly opposite. We will find out how many ways they will sit together, because actually that's kind of simpler. And then we will subtract uh, uh, that answer from this 7 factorial, and this will give us an idea about like how many ways they will not sit together. So this is kind of alternate uh, approach. So I will write here step 2. These two people or two representatives together. Now, this is exactly not the thing which we want. So we will eliminate that from our total number of possibilities. Uh, how can we make sure that these two representatives are together? Well, one way is to see that is, let us create a container in which these two people are together, and we will not disturb this container. So that means whatever happens, these two people, who are these two people? One from the richest representative, and another one is for the poorest country's representative. So that means out of 7 people, we will treat them as a bundle, as a unit, and place them in a container. And the remaining and the remaining 5 people, remember there are total 7 people. So remaining 5 people, they are free to arrange themselves, right? So now, if we want to make sure that these two representatives are together, we will place them in a container and we will never disturb that container. The remaining 5 people can have their freedom. So now, this gives rise to 6 factorial arrangements, because now there are 5 plus 6 technically units. The 5 free people with like unlimited freedom, and these two actually they behave as a one single unit. Uh, and there is another thing. Now remember, these two people can shuffle among themselves while still being in the container. So, and this still creates a situation where these two people are within that box. These two people can shuffle their arrangement within themselves, and since there are 2 people, so that gives additional combination of 2 factorial, because simply there are 2 people. So total number of ways uh, in in which these two representatives are together is 6 factorial. The original 6 units can be arranged, and then these 2 people shuffling themselves within that box. So that's our answer for step 2. Now remember, this is exactly what we do not want. So now in step 3, uh, we will simply take, so now 2 representatives, they represent complement of an event. So I will say not together will be simply subtraction of these 2 steps. So that would be 7 factorial minus 6 factorial into 2 factorial. Now 2 factorial is simply 2, because 2 times 1 is 2. So this will be 7 factorial minus 6 factorial and 2. So now, remember, 7 factorial is all the multiplication of all numbers starting from 7 all the way down to 1. 6 factorial is multiplication of all the numbers starting from 6 all the way down to 1. So that means there are 6 numbers common between 7 factorial and 6 factorial. And 7 factorial has one extra number, which is 7. So that means I can technically take common 6 factorial, the product of first 6 numbers from these two. And here we will still have the last 7th number, and here we will have 2. So this 7 is actually coming, because 7 factorial is 7 times the remaining 6 numbers. So you can call 7 factorial as 7 times 6 factorial. So that's the common part between these two numbers. I can take 6 factorial common, and that will still leave the last factor, which is 7, on the table. And here we have 2. So now the final answer will be 5 times 6 factorial, and that would be answer A. You can check the answer. Yeah, that's correct. Thank you very much.